How do you describe distance? With a number, obviously, length. But what about describing distance in relation to a coordinate grid, like on a map? Well, then you need two numbers, the lengths along the grid, as well as a formula relating those lengths to your distance. Now, what about if your grid is skewed? Well, then you need to specify a third number for your description, the angle of the skew, and then modify your formula. Let's extend this by asking, what if your grid is three-dimensional? Then you have not only three grid lengths, but also three angles that can be skewed independently. And so you arrive at 6 possible numbers to describe distance. Now, let's push it even further by asking, what if your grid isn't three-dimensional, but rather four-dimensional, with a slightly more abstract formula for distance defined on it? Well, then you need 10 numbers. And it's these 10 numbers that are so crucial for describing our spatio-temporal reality. This is dialect with the space-time metric. Consider two nearby locations on a map. How can we describe the distance between them? We can start by expressing such a distance in terms of the map coordinates, dx squared plus dy squared. But this won't yield the true distance between those locations, because for a map of something like the Earth, where a curved surface has been projected onto a flat one, an interval dx or dy here on the map doesn't represent the same distance as an interval dx or dy elsewhere on the map. Moreover, the true angle between dx and dy may not be 90 degrees. To calculate the actual distance represented by this coordinate distance on the map,